Hey guys, so today I'm going to be doing something a little different from other videos. I'll be discussing Zeno's dichotomy paradox. It's like this metaphysical thought experiment, and it sort of involves a bit of both physics and philosophy. And it's a paradox because it uses seemingly reasonable premises to get to a completely absurd conclusion that sort of contradicts our reality. So, without further ado, what is dichotomy paradox? Well, as you can probably guess from the name, it was created by this Greek philosopher named Zeno, and basically, this is how it goes. So, let's say we have a person. Let's say this is Zeno, and they want to walk a certain distance, and we'll say that this distance is d. And actually, let's call this the x-axis. So now, if we just use the distance formula, and so if we assume that this he travels at some constant velocity v, then we know that the time it takes is just the distance over the velocity, and it has to be a finite time. But Zeno's dichotomy paradox argues that it actually takes an infinite time for him to travel this distance d. And here's why. So let's say that Zeno travels distance d over 2, and this takes some finite time. Let's say it's t. Well, he still has to travel another d over 2. Now, let's say he travels another distance, and he travels d over 4. So now he's at 3d over 4. Okay, now let's say he travels d over 8. And so this takes another finite amount of time, which is t over 2, since he's traveling at constant velocity. And this takes another finite amount of time, which is t over 4. And then let's say he travels d over 16, and then d over 32, and then d over 64. And as you can see, there's technically an infinite amount of finite times he's traveling. And so Zeno's dichotomy paradox argues that since there are infinitely many infinitely many time intervals that he travels in his trip from to distance d, um, it would take an infinite amount of time to travel to distance d, since each one of these are finite and are greater than 0. And then you could even take this a step further and argue, or Zeno himself took it a step further and argued that since this distance d is some arbitrary value, technically you can plug in any distance for this, which means that movement is impossible because it would take an infinite amount of time to move any distance, which obviously we know is not true. And so it seems pretty reasonable, and you might think, well, how does this work? Like, he's right, it would take an infinite amount of time if we think about how these are finite. Well, his conclusion that all movement is impossible or that takes an infinite amount of time is based on two premises. So the first one is that distance is composed of infinitely many smaller distances. And I think this one is actually correct because, well, we see it all the time in physics, actually. So, for instance, the formula for work, if we use the line integral version of the formula, it looks like this. And dr is just an infinitesimally small displacement. So if you're finding the total work, you're just adding up the forces over all these tiny displacements, which is basically what an integral is. And so the first premise is correct. And now for the second premise, it states that adding infinitely many finite quantities or values will be infinity. So since all these times are finite, and they're greater than 0, and we're just adding them up, it should, and since we're adding the infinite amount of times up, it should eventually be infinity. And we can actually see that this paradox falls apart because the second premise is false. And so, well, obviously Zenos was an ancient Greek philosopher, so the knowledge in the field of math at the time is nowhere near as extensive as it is today. And so today we know about geometric series, and we can actually use the geometric series to model the situation. So we have 1/2 to the power of n from n equals 1, since he initially travels d over 2. Actually, sorry, this would be d over 2 then. Okay, so from n equals 1 to infinity. Okay, that was terribly drawn. And because we're adding up an infinite amount of time intervals, and each one is half the size of the previous one, or distance intervals rather. Okay, and then so actually no, we should use time because we want to show that it's the time that's finite. Sorry about that. So so basically Zeno's paradox states that it should take an infinite amount of time to travel this distance. And I'm trying to show that it's false by showing that it's a finite amount of time. So it would be t over 2 to the power of n. And there's actually a formula for adding up infinite geometric series. And it would be the first term over 1 minus the ratio. And so the first term, if we plug in 1, is just t over 2. And the ratio between each term, well, this is the same thing as t times 1/2 n. Actually, no, wait. Okay, so it is t times 1/2 n. So I actually have to take t out. So t times 1/2 n, and so the ratio would then just be 1 minus 1/2, which is then just 2 times t over 2, and we get t. And so if we plug in any value for this first time interval, we can see any value for t, we can see that it would be finite. And so that's one way to show that this paradox doesn't work, because the second premise is invalid. Another way is actually just to use a square. So let's say we have a square, and let's say each of the side lengths of this square is just rad d. Well, then we know that the area of the square should obviously just be d. And we can use the square to represent Zeno's displacement. So initially we can split this in half like this, and we know that this area would then be rad d over 2, and this could represent his first trip here. And we could split this in half again, and we can see that this would be rad d over 4. And we can split this in half again, and we can see that this would be rad d over 8. We can split it in half again. We can see it would be rad d over 16. We can split in half again. We would see it would be rad d over 32. Again, rad d over 64. And I think you can see now where I'm going with this. So we can see that adding up infinitely many finite non-zero quantities, which are positive, does not equal infinity, or does not necessarily equal infinity. Because we know that this square, so if we plug in any value for d, we'd have some finite number. And we can see that adding up infinitely many of these tinier, or increasingly, or increasingly tinier pieces would just yield a finite value. And so we can see that Zeno's dichotomy paradox, or Zeno's conclusion using his paradox, that all movement is impossible because it would take an infinite amount of time, is false. And yeah, so that's pretty much it. Thank you for watching.